Hi friends, the objective of this video is to make you familiarize with computer architecture and microcontrollers. We know that computers play a major role in all fields of life, starting with vacuum devices, changing to transistors, ICs, VLSI technology. Now we have entered into fifth generation of computer. As all of are aware, a computer is nothing but an electronic machine that manipulates data according to a list of instructions. Any computer consists of an input unit, processing unit, output unit, and storage. The input unit is through which we can enter data into the system. Processing unit will process the data as per the instructions given to the system, and the result will be made available through the output unit. And there will be a storage device or a memory through which data is entered into the system, data is processed, and data is stored. So in short, we can say computer can accept data, process the data, give the result according to the instructions given, and will store the result. So let us have a basics or introduction about CISC and RISC architecture. We know that CISC architecture, CISC stands for complex instruction set computing, and RISC stands for reduced instruction set computing. So these two terminologies are very, very important as far as computer architecture is concerned. CISC take its name from large number of instructions and addressing modes. So it has more large number of instruction sets, memory-oriented instructions, and generally CISC architecture takes two operand format with the source and destination. So it can be register to register operation, can be register to memory operation, can be memory to register operation, so on, so on. And another feature of CISC processors are that the instructions have or variable length. It can be single cycle instruction, two cycle instructions, three cycle instructions, and so on. And length varies according to the addressing modes. So complex addressing modes are available with the CISC architecture, and the length also varies. And instructions that require multiple clock cycles to execute. The basic philosophy of CISC design is, in the early days of computer industry, compiler technology basically do not exist. Programming was done using machine code or with assembly language. So that is to make programming easier, computer architects created more and more complex instructions. The attitude at the time was hardware design was easier than compiler design, and the complexity went into the hardware. That's how we have the complex instruction set computing. Another parameter that encouraged complex instruction was the lack of large memories. We know that memories were too expensive in olden days, and therefore all computer architects tried to use minimum external memory to any system. So there also, to improve the performance, the architects tried to improve the performance by means of instructions only. And those instructions would try to do as much work as possible. The processor design philosophy eventually came to known as complex instruction set computer, or in short CISC. Now about RISC, reduced instruction set computing. It uses small, highly optimized set of instructions rather than specialized set of instructions often found in other type of architectures. Here, the instructions are of same length with reduced number of instructions, less complex and simple instructions. The control unit is basically hardware control unit. Instead of microprogrammed control unit, generally RISC architecture make use of hardware control unit. Few addressing schemes are only available with RISC architecture. Rather than memory addressing mode, there are only register to register addressing operations, etc. associated with the RISC architecture. So instructions are confined to load and store set of instructions. Many symmetric registers are organized into a register file. So basically, register-oriented architecture. The design philosophy of RISC architecture was brought out in the year 1980s, and a considerable amount of effort was put into designing chips for parallel computing with inbuilt communication links. Instead of making faster chips, large number of chips would be used, dividing up problems among them. And we know that pipeline technology was employed that time. Pipelining means the process of overlapped execution, wherein when one instruction is fetched and one instruction is entered into the decoding stage, the subsequent or the next instruction in the sequence will be brought into the instruction register. While the first instruction enter into the execution stage, second instruction enter into the decoding stage, while third instruction is fetched. So this process of overlapped execution is referred to as pipelining, which in effect helps in improving the speed of the memory and also the efficient utilization of resources. So we can see the comparison between CISC and RISC. CISC architecture, the emphasis was on hardware, whereas for RISC architecture, it is on software. CISC architecture uses multi-clock, means variable clock, and complex set of instructions, whereas RISC architecture employs single clock and reduced number of instructions. Basically, CISC architecture employs memory-to-memory set of instructions, whereas RISC architecture employs register-to-register instructions. The coding, the small code, half cycle per second, etc. instructions were available with CISC, whereas low cycles per second, large code-sized instructions are with RISC architecture. Transistors were used for storing instruction with CISC, spent more transistors on memory registers in the case of RISC. So these are the important features or comparison between CISC and RISC architecture. So very important concept depending on the type of application, depending on the users, depending on technology. So we have in market, we have CISC and RISC architectures. Another category of processor architecture was based on the memory available with the computer, named as von Neumann and Harvard architecture. Von Neumann architecture is a digital architecture whose design is based on the concept of stored program computers, where program data and instruction are stored in the same memory. We might have heard of stored program concept. So architecture based on stored program concept was von Neumann architecture, and this architecture was designed by mathematician called von Neumann in the year 1945. Please do remember that von Neumann architecture is also referred to as Princeton architecture because the university, the von Neumann mathematician was associated with the Princeton University, and this university has come out with this type of architecture wherein we have same memory space for program and data. So you can see the diagram here, memory system, same memory. So address and data are accessed by the processor from the same memory. So it is not possible that you can have simultaneous access of instruction and data with the von Neumann or Princeton architecture. Now coming to Harvard architecture, there is another university. They derived a concept or computer architecture which employs separate memory space for instruction data. That is shown here. It basically developed to overcome the bottleneck of von Neumann architecture, because in the case of von Neumann architecture, you have common memory. Therefore, it is not possible that you can fetch instruction data simultaneously, and that put in restriction on the time of operation. Whereas with Harvard architecture, you have separate space for memory as well as instruction as well as data, and therefore simultaneous fetching and simultaneous execution is possible with Harvard architecture, thereby improving the speed. So you can see the difference here. See that in the Harvard architecture, you can see that instruction access and data access can take place simultaneously, whereas with the Princeton architecture, that type of access is not possible. So we'll summarize the differences between von Neumann and Harvard architecture. Neumann architecture based on stored program concept, Harvard architecture based on Harvard Mark I relay based model. Same physical memory is used for instruction data in the case of von Neumann architecture, whereas separate physical memory is used for instruction and data. Common bus is for data and instruction transfer because only one is taking place at a time for von Neumann architecture, whereas for Harvard architecture, because simultaneous access is there, separate buses are for transferring data and instruction. And Neumann architecture, 2 clock cycles are required to execute single instruction, 1 clock cycle for fetching the instruction, and 2nd clock cycle for fetching the data. So 2 clock cycles are required minimum, whereas with Harvard architecture, we can execute the instruction if required in a single clock cycle because simultaneous access is possible. It is cheaper in cost. Von Neumann architecture is cheaper in cost because buses or associated buses is less with the von Neumann architecture, whereas Harvard architecture is costly because separate buses are required. CPU cannot access instruction data at the same time in the case of von Neumann architecture. It is possible to access both instruction data at the same time. And Depending on the type of applications, users may prefer to use von Neumann or Harvard architecture. We can see that DSP architectures, some of the microcontrollers are Harvard in nature, whereas commonly used microprocessors from Intel, etc., are von Neumann or Princeton architecture in nature. So this is all about today's video. So let us have more on number system and associated things in the second part of this video. Thank you.